All right, hi 11s, this is Mr. Lim here again, and this is our fourth video on intermolecular forces about now intra versus intermolecular forces. So let's get started. Okay, so we're going to be able to learn about the differentiating between intra and intermolecular forces, where they are, naming stuff, that kind of it. All right, okay, so let's have a look. Chemical bonding recap. So let's have a look back at the past. So different arrangements of electrons bring about different chemical bonding. So if you remember ionic bonding, you're transferring electrons from from one atom to another to make positive and negatives, right? If you're a metal, you'll just lose all your electrons to a sea of delocalized valence electrons, right? But in a covalent bond, right, we share electrons, or the sharing of electrons creates the bonds called covalent bonds, okay? So just to be clear, is the electrostatic attraction between, atom number 1 and the electrons and atom number 2, okay? So these are both positive, right? And these are negatives. So there is an attraction between these two, and there's an attraction between these two, but you should recognize that there is a repulsion between these two, and actually there's even a repulsion between these two, right? But the idea is that there's that balance between attraction and repulsion, and that will determine, well, how far away those two atoms are, but the idea is that you still have that attraction pulling them together, right? So a bond will hold oops, that's not what I wanted. A bond will hold particles together, okay, so we call them bonds, which are things that hold things together. An intramolecular bond are bonds within a molecule, okay, so that's the key idea, is that intra means within. These are the covalent bonds, okay, whereas the intermolecular bonds, right, are between molecules, and these are called van der Waals forces, right, or intermolecular bonds. Okay, so the key difference is this idea of within or between. Intra is within, inter is between. All right, so let's have a look at some examples. So let's do an examples like H2O. All right, so here is the electron dot diagram of H2O. Okay, well, I probably didn't need to draw it that way, but yeah, there we go. Okay, so V-shaped because it has 4 regions of negative space and 2 non-bonding pairs, right? But the idea is that if this is one water molecule in its V-shape, right, there can be a second water molecule in its V-shape here, and I'm just going to draw it out with the lines here. Okay, so to break this bond between them, this is an intermolecular force, right? This is a van der Waals force. This is very strong or weak. It's very weak, right? But to break this bond here, this is an intermolecular bond, right? And this is very strong. Okay, so it is the bond between it. This is the strong covalent bond, right? And these are the van der Waals forces. Okay, so those are the names of it. Those are the examples of, okay, can you see that is between two molecules and within a molecule there, right? And their nature's there, right? So let's have a look at the strength of the bonds. So between the molecules, which is what we said just then, between the molecules, the van der Waals forces are very weak, okay? Whereas within a molecule, that's the covalent bonds, the bonds are very strong, okay? So therefore, if we're talking about what to actually do, separating a molecules, so pulling the molecules apart from each other, does not require a large amount of energy, okay? So that's just to melting or boil them. But to break them apart, right, break apart the atoms from each other within the molecule requires a large amount of energy due to the strengths of those intramolecular bonds. So an example is, okay, here's that water again. Oops, that's what I wanted. Here's that water again, right? So to break the bond between these two here, which is to simply melt it or boil it, melt/boil, we break that bond, okay? Whereas to break this bond, this is a chemical reaction. Some sort of chemical reaction must occur to break that bond, and this requires a lot more energy than the melting or boiling, which requires much less energy. Okay, so the idea is that you would need to recognize when we're talking about intra and intermolecular bonds. We're going to be dealing with intermolecular bonds for a little bit, considering that's the name of this topic, right? But the idea is that you should be able to name them, you should be able to identify and kind of give examples and how to draw them, things like that. Okay, that's it. Adios.